In this video, we're going to calculate the wavelength and energy of a specific frequency of light. And so the frequency of light that we're going to be using in this case is 1000 hertz. And so a hertz is the same as 1/seconds or per second. And so when we calculate both lambda, which is the wavelength, and E, which is the energy, we're going to be using a few different equations. One of the equations that's relevant to determining the wavelength and energy of light is the equation for the speed of light. And so the equation for the speed of light, which is denoted as c, is nu times lambda, where nu is the frequency and lambda is the wavelength. And so if we rearrange that equation so that we're now solving for the wavelength, what we get is c over nu. And so c is determined to be in a vacuum approximately 3 × 10⁸ meters per second. And so if we now take that equation and we now plug in the values, what we get is 3 × 10⁸ meters per second over 1000 1/seconds. And so we can see is that the seconds cancel out, and what we get as our answer is 300,000 meters. Or if we were to turn it into scientific notation, it would be 3 × 10⁵ meters. And so this right here is the wavelength of light that has a frequency of 1000 hertz. The equation to calculate energy is equal to h nu, where h is Planck's constant, which is equal to 6.626 × 10⁻34 joules per second. So we can plug those values in, and so what we'll have is 6.626 × 10⁻34 joules seconds times 1000 hertz, or 1/seconds. So we can see the seconds cancel out, and what our final answer is 6.626 × 10⁻31 joules. So in this video, what we were able to do is calculate the wavelength and energy of light that has a frequency of 1000 hertz.